Okay, good morning or afternoon again. I have no idea when you're watching this. I'm going to do this without the webcam today. See how you like that better. But we're going to talk today about two sections. It's going to be, I'm putting my fingers up and you can't see that. We're talking about two sections, 1.5 and 1.6. 1.5 is all about triangles and 1.6 is about quadrilaterals. So that'd be three-sided shapes and four-sided shapes. So before we start here, take a second and take a look at this problem on the screen there for you right now. You're going to want to draw that out and then mark the things on it that it says are true right here. So pause your video and then come back in just a second. Okay, so on this one, we've got a couple of things going on here. We've got, first of all, ray AE bisects angle BAD. So we'll find ray AE, that's the ray, goes off forever in that direction. And then angle BAD, A is the vertex. And so AE is bisecting this angle. And the only way we'd have to mark that down on our paper is that we know that bisecting an angle creates two equal angles. And so that's how we'd mark that. Next up, we have that E is the midpoint of BC, segment BC. So there's segment BC, there's E, that's the midpoint. And again, we don't have a midpoint mark, but what we do have is, knowing the definition of a midpoint, each of these two sides is going to be the same. So we can mark those as congruent. So again, we're putting these up here because these are very common things I see. When you get to a question that says midpoint, and you're like, you can't just circle the dot and say midpoint. That doesn't work. You have to know what a midpoint means before you can actually answer that question. So we're going to start with section 1.5. This one's all about triangles, and all of these words are words you've heard before. So rather than having you go through and list out or look at those pictures like we did the last time where you say, okay, these are 4 examples of a right triangle. These are 4 examples of things that aren't a right triangle. I have a feeling that most of you know what right triangles are. And so I'm just going to go ahead and kind of run through those really quickly here. You can certainly pause these. You can go back and listen to them again or whatever, but make sure you get these written down either in the note packet that I'm providing on Canvas if you want to print that out, or just in your glossary. You need these written down somewhere for later on. So it's going to look a lot like this. I'm going to go ahead and, I don't know why I did that. I'm going to go ahead and switch over to the document camera here so I can draw a little bit easier on here. So we're going to start off with a right triangle. And a right triangle is, I'm going to leave off the whole a right triangle is, but it's going to be a triangle with, if you're okay with me using that symbol for with, one right angle. And then in your glossary or in this page, I want you to go ahead and make a picture of what that would look like. The thing we really need to have is that right angle symbol there. To know it's a right triangle, we need that right angle symbol. Next up, we've got an obtuse triangle. So a right triangle was a triangle with one right angle. An obtuse triangle is a triangle with an obtuse angle. And so what that might look like is something like that. There's no symbol for obtuse, but obviously bigger than 90 is what we're looking for in that picture. Now, an acute triangle. If you're following this pattern, you're going to think, well, an acute triangle would be a triangle with one acute angle. But take a look at these. There's an acute angle, there's an acute angle, there's an acute angle, there's an acute angle. So an acute triangle has to have not just one, not just two, but actually all. So a triangle with all acute angles. And so that's going to look something like that. Okay, now these 3 words, scalene, equilateral, and isosceles. The first 3 all had to do with angles. The second 3 all have to do with sides. Now we've used that word before, equilateral. That's going to be a triangle with 3 congruent sides. Now think about how I'm going to draw that. In order to know that something is equilateral, I've got to put the marks on it. 3 equal sides. Now, one of these you've probably heard before. I'm going to guess isosceles. That's the one that's got 2 equal sides. Or 2 congruent sides. Something like that. And then a scalene triangle is just where none of them are equal. So we've got a triangle with no congruent sides. And so you might draw a triangle that looks something like this, where that one's different from that one, it's different from that one. Oops. So we know that those are all different. Hey, second hour starting. Yay. Okay, so those are definitions for triangles. Now, a triangle can be more than just one of these. For example, a triangle could be isosceles and acute, or it could be isosceles and right. There's some that can't go together, though. For example, it's not possible for a triangle to be equilateral and obtuse. Just can't happen. We'll talk about why that is a little bit more later on, but if you try to draw a triangle that's obtuse, there's just no way to make the sides equal. Okay, coming on back here. I'm going to do this one first. There's a few definitions here for isosceles that are going to be really important. On that page over there that I just had up on the screen, you saw the bottom of that. If you printed out the packet, you've got a space for this on the bottom. These are vocabulary words specifically for isosceles triangles. And so a few of these are going to be kind of pretty simple, pretty common names. But some of them are a little harder here. So the first one we've got is the base, I think. Yeah, there we go. The base is the non-congruent side of an isosceles triangle. Now, one of the biggest things that you have to know about the base is it does not have to be the bottom in any way. So here the base is over here on the side. The base could be up here on the top, depending on how I drew the triangle. It's just that it's the non-congruent side. The base angles, then, are the angles that touch the base. So you've got an angle that is between one of the equal sides and then the base. And there's another one over here between this base and this equal side. Then you've got the vertex angle. That's the angle between the 2 congruent sides of the triangle. We call that the vertex. Now, your book doesn't do this, but some do. Some books call the 2 congruent sides the legs of the isosceles triangle. Your book doesn't do that because it uses the word leg like that in a different way. And it's not like it's uncommon either way, but just if you see legs of an isosceles triangle, they're talking about the congruent sides. Before we jump into too much more, just a couple of things that your book really wants to point out here. These are some things that when you're looking at a picture, you absolutely cannot assume these things are true. So if you see 2 lines or line segments or rays or anything like that that look parallel, they're not unless they're marked parallel. They have to have those little arrow marks. So if you remember, unless, come on, pen, there we go. Unless they have these little marks, they're not parallel. So those are parallel, those not parallel, without the marks. Same thing with perpendicular. You cannot assume that lines are perpendicular unless they are marked perpendicular. And the way that looks, again, is that little square symbol. So that's perpendicular, otherwise you can't assume that. And then the same thing about congruent. Unless they are specifically marked with those congruent symbols, so either the congruent angle symbol or the congruent segment symbol, they're not congruent. Doesn't matter how close they look, they're not unless they're marked. That's very important. Okay, let's just go ahead and take a look at this one. It says closing question, but we're going to keep going after this and do section 6. All of you be able to type into the box here. So how could you describe that triangle as precisely as possible? Okay, so there's a couple of things that we've got going on here. The first thing I'm seeing is we've got two congruent sides. That makes it isosceles. It's one word I can spell. And then we've got this angle right here, which is definitely bigger than 90 degrees. That is obtuse. So it is an isosceles obtuse triangle. Okay, jumping right along here. Section 1.6 is about special quadrilaterals. So we just talked about the vocabulary that goes with triangles. Now we're going to talk about the vocabulary that goes with quadrilaterals. This one I'm going to put up the pictures and you're going to try to write down the definitions and then we'll talk about them. So you will have to do a little responding in this video. So define and classify quadrilaterals. Some of the words you're going to see: trapezoid, kite, parallelogram, rhombus, rectangle, and square. And we will definitely be coming back to these later on in the year. This is just a really quick kind of make sure we're all talking about the same things. Real quick reminder again: parallel, perpendicular. You'll see those symbols in the next couple of slides here. Okay, so in this activity, you're not working with your group, sorry. We're going to write a definition. Remember, a good definition does two things. It classifies and it differentiates. Classify meaning that it tells you what it is. Differentiating meaning it tells you how it's different from the other things like it. So from the ones we just talked about, an equilateral triangle is a triangle. It's what it is. That has three congruent sides. That is how it's special. Okay, so first one up, take a look at those. Those three are trapezoids. Those three are not trapezoids. I didn't have you do that homework question, so you probably didn't get that one. So write your definition down, and then we'll come back. Okay, so if you look at these trapezoids, you've got a shape here with parallel sides, a shape here with parallel sides, a shape here with parallel sides, but not all of them are parallel. And this one has 5 sides, and this isn't quadrilateral at all. So what we're looking at here is a trapezoid being a quadrilateral with exactly one pair of parallel sides. Can't have 2 pairs. It's got to be a quadrilateral, but that's what a trapezoid is. Next up, we've got kite. This one's actually kind of hard to come up with the wording on this one, but hopefully you kind of get the idea of what we're going for here. Okay, so if you look at these shapes, again, we've got quadrilateral. So we'll start with that. A kite is a quadrilateral. Now, when you're looking at this, we've got one pair there of congruent sides, one pair there of congruent sides. Same with this, congruent, 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 congruent. What's different, though, is if you look over here, this shape has a pair of congruent sides and another pair of congruent sides. How is that different? Well, on this shape, the congruent sides are touching each other. These congruent sides are touching each other. On this shape, the congruent sides are opposite of each other. So that's the big difference. A kite has 2 pairs of parallel sides that are consecutive. Consecutive just meaning that they are one right after the other. Another word, if you wanted a different word that you could use, could be adjacent. Adjacent just means next to. But that's the key for a kite. 2 pairs of consecutive or adjacent congruent sides. Okay, next up, parallelogram. I have a feeling a lot of you remember what this one is from, probably in middle school. So again, a parallelogram is a quadrilateral. The big difference here, it's got 2 pairs of parallel sides. Where a trapezoid only had 1 pair of parallel sides, a parallelogram has 2 pairs of parallel sides. Okay, next up we've got the word rhombus. Take a look at those 2 that are rhombuses and those 3 that are not rhombuses and see what you think. So here's the first thing I want you to look at. The little arrows because they've got two pairs of parallel sides, this is one that we can say, rather than saying a rhombus is a quadrilateral, we can say a rhombus is an equilateral parallelogram, or it is a parallelogram with equal sides. This one, if you want to kind of go with is a blank that blank, you could say a rhombus is a parallelogram. That's not how you spell it. Ogram. That is equilateral. Or if you wanted to not use that word equilateral, that has four congruent sides. Any of those definitions would be fine. They all mean the same thing. This is just the shortest way of writing it. Okay, similar idea for a rectangle. Now, one thing I want you to make sure that if you put this down in the definition, that you take it out. This one has 90-degree angles. Do I know that this one has 90-degree angles? No. So a rectangle is not a quadrilateral with 90-degree angles. It is a quadrilateral with equal angles. So a rectangle is an equiangular parallelogram, or you could say a parallelogram with four equal angles. And we'll talk later about what those angles might be. But in general, they don't have to be 90 all the time. That's true sometimes, but we don't want to be trying to claim things that we don't know are true yet. And then the last one is a square. Take a second and try to write the definition of a square. Okay, so you can actually do this one really, really short or really long, depending on how you want. Here's a few options. A square is an equilateral rectangle. That's one. A square is an equiangular rhombus. That's another. A square is a regular quadrilateral. That's fine. You could even go with something like a square is a parallelogram with equal sides and equal angles. That says the same thing as all of these. Equilateral rectangle, remember a rectangle is equiangular, so equal sides and equal angles. Or an equiangular rhombus, equal angles, but a rhombus already has equal sides. Regular, if you remember that one from back at the beginning of the week, regular means equal sides and equal angles. So lots of different ways to write that one down, but remembering that it's equal sides and equal angles to make a square. Okay, so just again, this is one more thing to keep in mind. Just because it looks like a square doesn't mean it's a square. Just because it looks like a rectangle doesn't mean it's a rectangle. You really need to be careful with looking at the actual markings on the picture. Okay, go ahead and try that one out. Draw a quadrilateral ABCD with segment AB parallel to segment CD and segment BC equal to AD. Make sure you're accurately marking the figure, and then we're going to talk about what kind of shape this is. So draw that out on some scratch paper for me. Okay, let's take a look at what we've got. We've got quadrilateral ABCD. I'm going to draw it like this. I don't think it's a rectangle, but you never know. A, B, C, D. Okay, taking a look back real quick here. We got to mark AB is parallel to CD. Okay. And we've got to mark that BC is equal to AD. So BC is equal to AD. And so the question is, well, what kind of shape does that have to be? Do we know for sure that it would be a rectangle or a rhombus or anything else? And really, really, really have to be careful here. We know that it's got one set of parallel sides. That would make it a trapezoid. Do we know anything else? The two equal sides don't tell us anything on their own. So in this case, I think the best we can do is a trapezoid. Maybe if we had a little bit more information, we'd be able to say something else, but at this point, we don't have any more information. So that's all we got. Okay, so the homework today is going to actually be from two sections. which means it's going to have kind of two, below this video, you're going to see homework from two different sections. I'll try to keep it short overall, maybe 15 questions total from section 1.5 and 1.6. I don't think you need to be doing 20 of them. And remember, tomorrow in class, we're going to have some time for review, some time for homework questions, and just some time to practice with this kind of stuff. So I will see you all tomorrow.